Hello all, this is Pushpa Rani, MLR Institute of Technology, Department of CSC. So today I am going to discuss about the topic in discrete mathematics, equivalence implication. So there are two methods to find whether the two prepositions are equivalent or not. So in the last class we already discussed about equivalence implication means consider the two prepositions. For example, P implies Q, that is equivalent to negation P or Q. These two prepositions are said to be equivalent. Then whatever the truth values that are present in the P implies Q, the same truth values are present in the negation P or Q. Then the two prepositions are said to be equivalent prepositions. There are two methods to find whether the two prepositions are equivalent or not. The first method is already discussed in the previous lecture, that is called as a truth table method. In truth table method, we are going to apply the connectives like and, conjunction and disjunction, implication, biconditional, conditional statement or negation. With the help of the connectives, we have to prove that whether the statement 1 is equivalent to statement 2 or not based on the truth values. So that is the first method. And coming to the second method, we are going to applying some laws. Okay, by applying some laws, we need to prove that LHS is equal to RHS. If LHS is equal to RHS, then the two prepositions are said to be equivalent prepositions. So in this video, we are going to discuss about what is meant by equivalence implication and what are the examples we need to understand. Before that, we need to understand the laws which are helpful for the proving whether the two prepositions are equivalent or not. So that is the second method is also called as replacement process. Why it is called as replacement process means we need to apply the formulas in the place of preposition. For example, P tends to Q is a preposition or it is a statement. That statement is replaced with the help of the corresponding formula negation P or Q. That is the corresponding formula for P implies Q or P conditional Q. That means we need to replace this statement with another statement. That's why this process is called as a replacement process. For the replacement process, we need to apply some laws to prove that whether the two prepositions are equivalent or not. That is, LHS is equivalent to RHS or not. We need to prove the LHS is equal to RHS. Consider the laws. First one is P and negation P. Okay, P and P or negation P is true. P or negation P is true. It is excluded middle law. Excluded middle law. We already proved that take P and negation P, and we have to prove that it is a tautology. P or negation P is a tautology. That law is called as excluded middle law. Second one is P and negation P is a false. It is a contradiction law. These laws are useful to find whether the two prepositions are equivalent or not. So P or false, that is P only. So P or false is P only. That is P. P is nothing but a true or it is a false statement. And false means what? It consisting of false only. If you take P or P, P or false, what it shows? True or false is true. False, false is false. Then what is the equivalent preposition? That is P only. That is called as a identity loss. P or false is P and P and true is P. P and true. For example, P, true. P is a true and false. True is consisting of always true values. We take P and true. True is true only. True, false is false only. That is equivalent to which value? That is the preposition P. So that is P and true is true. These two are called as a identity loss. Third one is a P or true. P or true is a true. P and false is a false. These two are called as domination loss. These two are called as domination loss. And fourth one is a P or P is P only. P and P is a P only. That is called as a idempotent loss. These are two are idempotent loss. Next, negation of negation P is equivalent to P. That is a double negation law. So coming to the remaining laws, P or Q is equivalent to Q or P. That means in the place of P or Q, how to replace with Q or P, because these two are equivalent. These two are equivalent. P and Q is equivalent to Q and P. This is called as a commutative law. This is called as commutative law. Next, associative law. P or Q or R. Then P will be separated and Q or R. That is associative law. The same thing in the place of R, apply and. Apply and. Then P and Q and R. Then P is separated, Q and R will be take it as single preposition. Next, this is a associative law. That means P is associated with any one of the prepositions. Next, distributive law. P or Q and P or R. It is P is a common in two preposition. Then that can be distributed. P then or Q and R. That means P and Q, P or Q and P or R. P is distributed for both preposition. That's why it is called as a distributive law. Next, P and Q or P and R. Next, the common preposition in two prepositions is P only. So, P is separated, P and Q or R. This is called as a distributive law. So, most of the problems you are going to use the distributive law. Okay. So, to get the LHS is equivalent to RHS. Next, De Morgan's law. So, negation of P and Q. So, that is a P and Q. So, the negation will be applied the inside of the preposition. Then negation, there is no negation for P. Then it becomes a negation P. So, this is and becomes R. Then negation Q. So, in the same way, negation P or Q. P or Q. Negation P and becomes R becomes and. Then negation Q. This is called as a De Morgan's law. Next. After that, P or P or Q. That is a P is common. Whatever the preposition that is common, that is equivalent to P. That is called as absorption law. Next, P and P or Q is equivalent to P. That is the absorption law. So, based on these laws, we need to replace the statement with the corresponding statement to get the equivalence implications. In the case of replacement process, what we are going to observe that LHS is equivalent to RHS or not. We need to prove that LHS is equivalent to RHS. Consider some examples. We need to prove that whether the two prepositions are equivalent or not. First example, show that P and P or Q. This is the LHS. V is equivalent to P. So, we need to take LHS and we need to apply the laws, whatever the laws that is discussed in the previous slides, apply those laws and prove that the final preposition is equivalent to P. Consider the preposition P and P or Q. This is the given preposition. Next, according to distributive law, we already discussed about the distributive law. The P is distributed to P as well as P is distributed to Q. Then what we are going to get? P and P or then P and Q according to the distributive law. In the exam also you have to specify which law is used for corresponding preposition. Then it is the good impression for the examiners. Next, after that, in those two prepositions, the P is a common. Take P as common. P. And what is the inside of the preposition? That is, take it as P. P and Q. So, what is the relation? We are going to get P, then P, P and P. After that, P and Q. So, the way same thing we are going to get according to the idempotent law. So, P and Q, P or P and Q is equivalent to P according to the absorption law. What is the RHS value? RHS is equivalent to P. RHS is equivalent to P. So, that is the corresponding equivalence implication for the given LHS is equivalent to RHS. We need to apply which law you are going to apply to get the RHS value. You have to write the preposition or you have to specify the law inside the parenthesis. Consider the second example. P implies Q. That is the LHS. That is the LHS. Then P implies P and Q. That is the RHS. Either you take LHS or it may be RHS. You take any one of the preposition, but it should be equivalent to the given statement. Take P implies P and Q. P implies P and Q. So apply the conditional statement. P implies Q is equivalent to negation P or Q. This is called as a conditional law or it is a implication law. So take what is P in the place of the given statement P only. Implies what is Q in the place of Q? P and Q. So consider this is as a P, this statement as Q. Apply that law, then what is the given preposition becomes? So that is the negation P. In the place of P, P only, negation P. Or what is the Q in the place of given statement P and Q? So P and Q. So after that we need to apply the distributive law. That means negation P is distributed for both prepositions. Negation P or P. Negation P or P. Next, there is and symbol. Write the and symbol. Again, negation P is distributed to Q. Negation P or is there. Negation P or Q. So it is a negation P or P becomes a tautology. That is true. And negation P or Q must be written as it is. Okay. So true and P, whatever the preposition, that becomes a P only. That is a P. Negation P or Q. According to the formula, this is a conditional law. You have to apply either left hand side or it is a right hand side. Negation P or Q is implies to what? That is equivalent to P tends to Q. Then we take RHS and we need to prove that that is equivalent to the LHS. P tends to Q. That is called as a equivalence implication. That is the second example. Consider the third example. Prove that P tends to Q and Q tends to R is equivalent to P tends to Q and R. Okay. Take LHS and we need to prove that at last RHS value. What is the RHS consisting of? P implies Q and R is present on the RHS. Take LHS, apply the laws for the replacement process, and we need to prove that given LHS is equivalent to RHS. What is the statements that is present in the LHS? P tends to Q and Q tends to R. So we know that it is according to the implication law or it is a conditional law. We know that P tends to Q is equivalent to negation P or Q. What is present in the place of P or Q? P or Q only. We are going to get negation P or Q as the first preposition. There is a and, write and as it is. Next, P tends to R. P tends to R. What is present in the place of P? P only. So it becomes a negation P or. What is present in the place of Q? Or is there. Negation P or R. Negation P or R according to the implication law or it is a conditional law. Next, what is the common preposition? If any common preposition is present in, then we are going to immediately apply the distributive law. What is the common thing in both prepositions? Negation P. So negation P, take it as out, that is negation P. Then what is the operator in both prepositions? That is a or operator. Then Q and R. Suppose if you divide again, then we are going to get the same preposition, negation P or Q and negation P or R only. So that is the distributive law. According to the P tends to Q, you have to, this is both are equivalent, na? Both are equivalent, then you have to apply either LHS2 is equivalent to RHS or RHS is equivalent to LHS. So take negation P or Q implies Q and R. Then what is the equivalent preposition? P. What is P is there in the place of P? P only. P tends to. What is there in the place of Q? Q and R. So write the same thing here according to the implication law. According to the implication law. So that is the third example. Now consider the fourth example. Show that negation of P biconditional. It is a biconditional to Q is equivalent to P biconditional negation Q. So this is the LHS and this is the RHS. We considered as LHS, and at end we have to prove that the given LHS is equivalent to RHS. First we should know what is the biconditional law. Biconditional law means P biconditional Q, that is equivalent to P implies Q and Q implies P. Q implies P. This is the biconditional law according to the definition of biconditional law. First, so we have to give the importance for the innermost preposition. In the case of innermost preposition, what is the connective? That is the biconditional. According to the biconditional law, so write P negation right as it is. P implies Q. It is written as P tends to Q and Q tends to P according to the biconditional law. That means biconditional law divides the given prepositions into two parts. First part is P tends to Q and Q tends to P. It is a biconditional law. So we know that what is a conditional law? P tends to Q. What is the conditional law? Negation P or Q. This is the conditional law. We know that conditional law. So we need to apply the conditional law for both prepositions. So before applying the conditional law, so we need to apply the negation for the inside of the preposition according to the De Morgan's law. If the negation is applied for the inside of the preposition, remember the two things. One, so first thing is the parenthesis becomes cancelled. Second thing is in the place of negation and becomes or becomes and. That means it will be reversed. It will be reversed. First thing is the innermost parenthesis has been removed. Second thing is if the negation is applied for the inside of the preposition, then and becomes or becomes and. Apply the De Morgan's law for the given preposition. First step is we need to apply the biconditional law according to the P implies Q, P tends to Q and Q tends to P. So there are two prepositions. Write negation as it is. That is step number 1. Next, apply the biconditional law. Apply the biconditional law. So that is step 1. That is already completed, biconditional law. Next, according to De Morgan's law, so apply the negation inside of the preposition. Then negation. This is the first preposition. Negation is applied for and it becomes or. Then the same negation is applied for the second preposition. Negation Q tends to P. Observe the first statement and second statement. In the case of first statement, there are two parentheses are there. When we apply the negation for the inside of the preposition, the two parentheses becomes only one parenthesis. This is called as a De Morgan's law. After De Morgan's law, then we are going to get the two prepositions. For these two prepositions, apply the implication law. So what is P tends to Q? P tends to Q is equivalent to negation P or Q. Negation P or Q. Okay. So apply the negation P or Q. So write the negation. So negation write as it is. P tends to Q. P implies Q or P conditional Q. What is the formula? Negation P or Q. So the two prepositions consisting of P, Q only. Write negation P or Q. Write or as it is. Again Q tends to P. Negation is there. Write negation as it is. Q tends to P is there. For this Q tends to P, again apply the conditional law. So what is there? Q tends to P means Q tends to P is equivalent to negation Q or P. Negation Q or P. Right? Negation Q or P according to the implication law. Next, according to De Morgan's law, apply the negation for the inside of the preposition. Negation, negation P. So negation, negation P according to the double negation law, it becomes a P only. So P. Again negation or becomes and. There is no negation, negation Q. That is the first preposition. Next, there is a or operator, write as it is. Again, negation is applied for the inside of the preposition. Negation, negation Q. Negation, negation Q becomes Q only. Becomes Q only according to the double negation law Q. Then negation or becomes and. Negation or becomes and. There is no negation for the P, it becomes a P according to the De Morgan's law. In case of De Morgan's law, negation can be applied for the inside of the preposition. Next, P or P and negation Q. Okay, P and negation Q is the first preposition or. So, according to the commutative law, you can write it in any order. So, P is equivalent to Q is written as Q is equivalent to P. Or, so P or Q is equivalent to Q or P. So, there is a Q and P is there. You can write it in the order. First preposition is P, second preposition is Q. According to the commutative law, then negation P and Q. Negation P and Q. So, we know that what is P and negation Q? What is negation P and Q? So, according to the biconditional law, what is biconditional law? P implies Q is equivalent to P tends to Q and Q tends to P. So, what is P tends to Q? Negation P or Q. Okay, negation P or Q and negation Q or P. So, there is a negation Q or P is there. Negation Q or P is there. We can take it as a and. Okay, then automatically according to the biconditional law, that is equivalent to this statement is equivalent to. So, P tends to Q. This statement is equivalent to Q tends to P. According to the biconditional, we can write it as a P is biconditional of Q. P biconditional of Q. That is the next example. So that P tends to Q and Q tends to or implies P tends to or is a tautology. So, this is the entire preposition. This is the entire preposition, that is LHS is a tautology. That means we need to prove that at last we are going to get as a value as T. Value as a T. Then it becomes a tautology. So, P tends to Q. That is the entire statement you are going to consider as a LHS. Tautology is the RHS value. Means we need to prove that it is a true or it is a T. So, P tends to Q and Q tends to or implies P tends to or is the given preposition. Next, so write the statement. Write the statement for the entire preposition. First take the, so forget about the negation. Okay, forget about the negation. We'll apply at the last. P tends to Q means conditional law. P tends to Q is negation P or Q. Negation P or Q. Negation P or Q. And write as it is. Q tends to R. Q tends to R means negation Q or R. Negation Q or R. Next. So, after that for this entire preposition, you are going to apply the complication law. This, what is the statement? P tends to R means negation P or R. For this entire statement, this will be considered as a P, this is considered as a Q. So, directly we are going to get negation P or Q, that is Q. For this inside of the preposition, apply the implication law. So, after 2 steps, we are going to get the second statement. But in the slide, I have written directly, that means apply the implication law and also directly apply the indication law 2 times. Okay, first time is for the middle of the preposition. I am going to apply this is a P, this is Q. And for the inner preposition, again I apply the conditional law 2 times. Now, considering as a next step. So, this is the, after performing the 2 steps, we are going to get the statement as like this. Okay. Next, apply the De Morgan's law as well as distribution law. So, this negation is applied for the inside of the preposition. We are going to get P. Next, negation or applied for the inside of the preposition, we are going to get and. Again negation Q. Okay. Then again negation is applied. There are 2 parentheses. I already told that there is a 2 parentheses. Apply the negation for the inside of the preposition. It becomes 1 parenthesis only. Again negation of and becomes or. Again negation of Q becomes Q. Negation of and becomes negation of or becomes and. Again negation or. Remaining statement write as it is. Or is there, negation P or R. That is the De Morgan's law. Okay, De Morgan's law. Next. So, what is the statement? What is the next statement? P and negation Q write as it is. P and Q negation as it is. For these two prepositions, what is the, take it as a common preposition. Take the common preposition. Negation P. Negation P. So, negation P will be take it as out or. Next, Q and negation or. Q and negation or. So, that's write commutative law. Just change the order of the preposition. First write P, after that Q, after that or. Like that we have to follow the order. Negation P write first, then or is written. Write the next statement is Q and or. What is the leftover preposition or? Write as it is. Just you have to change the places according to the order. First P, then Q, then or. According to the preposition we can arrange the values. Next statement. So, according to the distributive law, so then P will be distributed. The P will be distributed to all the prepositions. P is there, or. P or negation P. P or negation P. There is and, right and. Next, Q. So, what is the Q? Q and negation Q. So, Q or negation Q. Again, or operator. What about the next one? Q is also distributed to or. Q or and. And is there, right as it is. Or negation or. Write the distributive law. Next, we need to apply the excluded middle law. Excluded middle law. P or negation P becomes a true. Next, right and. Next, negation Q or negation P, write as it is or. Q or. Again, there is a negation or union or it may be negation or becomes a true. Then it is a true, right as it is. True, right as it is. For this preposition, we are going to get true. Then for this preposition, Q or right as it is. Then use the parenthesis. Next law, according to the excluded middle law. So, again, true and any value becomes a P. Okay, true and P. True and P. That is a P only. That means negation P or negation Q. Or true and any value. That is the becomes identity. According to the identity law, true and P is P only. That means whatever the preposition that is present, that is the identity law. So, negation Q or negation P is negation Q or negation P is nothing but it is the given statement. So, it is a negation Q or becomes a negation P is a tautology. Tautology with any value. Tautology with any value. Tautology with any value is a given statement as a tautology. So, we are going to get the output as a tautology. That means it is always true. Tautology with any value. Negation Q or negation P is a tautology. Then according to the tautology, tautology with any preposition becomes a tautology. So, what we have discussed up to now, what is the equivalence implication? The second method called replacement process. In the replacement process, what we have discussed, we are applying the laws. By applying laws, we need to prove that whether the LHS is equivalent to RHS or not. We can understand the topic by taking some examples whether the two prepositions are equivalent or not. There are two methods to check whether the two prepositions are equivalent or not. One is a truth table method and second one is the replacement process. In replacement process, we are going to apply the laws to prove whether the LHS is equivalent to RHS. We can understand with the help of examples. Thank you.